Hello, my name is Claire Whang. I'm in Mr. Walsh's 16 to 18 class, and I'll be presenting on my arc length project. So when deciding what path I wanted to take, there is a park in River Edge that I really like to visit during the summer and during my free time to go on walks or to go on runs. And there's one particular path in Van Zwaan Park that circles around this area of trees. And that's the path that I outlined here. As you can see, there are some straight areas, but there is also one curved area that I'll be using for calculating arc length. And during the summertime, I do like to go on runs, and for this particular path, I wanted to find out how many laps around this path does it take to run 3 miles. So, in order to find out the distance around 1 lap, I had to calculate the straight distances added together plus the arc distance, and I've color-coded them here in order to find the total distance. So when finding the straight distance, I used the measuring tool in the Google Maps application, and I color-coded the distances for each of the straight lengths around this path. And I found that all of the straight lengths added together leads to a total of about 2,549 feet. Now, in order to find the distance of the curved area, I had to use the arc length formula. And the first step in trying to complete this formula was taking the different points along this particular curve using the Google Maps measuring tool and mapping that out on a graph. So you can see those points on the table on the right as well as the graph with the points labeled. And based off of these points, I was able to find the regression equation using the online tool, which is seen on the left above the image. This regression equation was used for the arc length formula. I found the derivative of this equation, and I plugged that into the formula using the upper limit of 964 and the lower limit of 0. I obtained the upper and lower limits from over here where you can see the plot points of the curve, where the highest x value used is 964 and the lowest is 0. So once plugging in these values into the formula, I found that the arc distance, or the arc length, is about 1,086.21 feet. So based off of this information, I was able to find the total distance of a single lap around this particular pathway using calculations, and I was able to compare that distance to the distance that Google Maps gave me for that pathway. So for the calculated distance, I knew that the arc distance calculation showed that the arc itself was about 1,086 feet, and all of the straight distances added together was about 2,549 feet, yielding a total of 3,635 feet. Now the total distance according to Google, if you look over here at an earlier slide, is 0.686 miles, which I circled in red. Now, knowing that a single mile is 5,280 feet, I multiplied that value by 0.686 in order to get a total of 3,622 feet. Now, this value is very close to the calculated value that I was able to obtain using the arc length formula, and I evaluated percent error to show how accurate this calculation was. And I found that the percent error was 0.36% error, not even 1%. Now, to tie it all together, I really wanted to answer that original question of how many laps around this path it takes for a 3-mile run. And the first step in this was finding how many feet was in 3 miles. So knowing that 1 mile is 5,280 feet again, I multiplied that number by 3 in order to get 15,840 feet. I took this number and divided it by 3,635 feet, which is the calculated number of feet for a single lap, and found that a total of 4.357 laps are about needed for a 3-mile run around this pathway. So that's something that I can definitely apply and use during the summertime when I want to go on my little runs. And this is the completion of my arc length project. I hope you enjoyed. Thank you.